Hey guys, hope everybody's doing well. So what I have today is I'm going to give you guys a case study. It's going to be underneath this video. I'm going to go over some problems that are going to be similar to like the ones you're going to see on the case study. You do not have to submit the case study. I just want you to try those problems on a sheet of paper, and if you have problems, let me know. And then we're going to do a quiz that's going to basically come directly from that case study. It'll be the same problems. It just is going to let me know if you knew how to do the problems or not. Alright, so this is just a combination of all three sections of the probability unit we've covered so far. So you guys were doing pretty well using the charts. That's all we're doing here. So for number one, this is going to show, for these examples, my first semester grades for math, and these are not real, I just made these numbers up. Male, female, A's, B's, C's, and F's. And then it has the total. And then I broke it down to second semester as well. Alright, so you're going to use these to answer questions. It says, a student from first semester is selected at random. Find the probability of each event. So A, the student is male. Make sure you go to the chart that has first semester. How many males were there in first semester? 26 out of 60. And then you can just reduce that. (13/30). Alright, a student has an A, so go back to that same chart for first semester. How many students had an A? Well, it was 15. DB right here. Out of the total, 60. This is basic probability. Alright, and that's going to be reduced to 1/4. C is the student is male given they had a B. So remember, you circle what's given. So we were given they had a B, so I'm going to circle this column. Remember, my denominator is in what I circled, as well as my numerator. My denominator is always the total, so 22. And then go back and look for that first piece, male, out of what I circled. 10 out of 22. Those are both divisible by 2, so it reduces to 5/11. D, the student is female and has an A. So how many females have an A? So let's erase this. This is easier if you do it in pencil. So I go to females and A. Well, it was 9 out of how many total? 60. The only one that's not going to be out of the complete total are the ones that say given. They'll have a different denominator. And of course, after you reduce it, it'll be slightly different. Those are both divisible by 3. So it's going to be 3/20. Sorry, this is kind of cramped. I meant to space it out before I printed it. Alright, and I'm actually going to add one I forgot to put on there. So we're going to do E, and I'm going to write it right here. Probability the student has an A or B. So remember, I circle my A's, I circle my B's. They don't overlap, so that means they're mutually exclusive. So I just add the two totals. 15 plus 22, and then put it over the grand total. So equals 37/60. Now what do you do when they do overlap? So we're going to do an F. We're going to do student. Can y'all hear my crazy family down there? I'm sorry. Student has an A or is female. Alright, so you circle both. We're going to circle A's. We're going to circle females. Notice they overlap. Oh my gosh. I'm so sorry. Let me go shut this door. I'm not sure that's going to help, but we'll see. Okay. Student has an A or is female. So they overlap. So you add the totals again. There's 34 females and there was 15 A's. So we're going to do 34 plus 15, but remember the thing that was circled twice? You have to subtract it. So do 34 plus 15 and then subtract that 4. You're going to get 45 over your 60 and then reduce it. 45 over 60 reduces to 3 over 4. Alright, sorry that's so messy. And if y'all have questions, remember, message me and ask. Don't sit there and be confused. Alright, also on the case study, it's going to ask you to combine the two charts. So this says for year long. So you're going to add how many males had A's. Well, 6 and 3, there was 9 that year that ended the class with A's. How many females had A's? Well, 9 and 7. That's going to give me 16. And then the total, 15 and 10, that is 25. Plus, you could have added 9 and 16. You would have still gotten 25. So you just go through and you add this chart. I just wanted y'all to not be confused by what that's asking. So I'll go ahead and give you a sneak peek of this case study. Here's the case study. You guys are going to be talking about House of Representatives as well as the Senate. So down here, when it starts talking to you about members of Congress, well, Congress is made up of the House of Representatives, and it's also made up of the Senate. So that's why you're going to add those two charts. It's going to look exactly the same. Just remember, you're going to add these together. So for example, when you make your new chart, you'll do 213 plus 41. It goes in that same spot for males. You'll do 19 over or plus 4. 232 plus 45. So don't let that confuse you. Also on the case study, it talks about independent and dependent. I want you guys to really think about that. I didn't know how to make a practice problem without giving you the answers, so I want you guys to think about A. There's also one that involves mutually exclusive, and if you rewind this video, I did tell you when something is mutually exclusive versus not. So I'm going to let you guys think about E on both number 3 and number 4. Alright, like I said, message me if you have any questions, and hope everybody's doing well and has a great night.